Hello students, a warm welcome to all of you in ITLS Academy and also welcome to all in our 3 months online certification course on topic nanobiotechnology. Today we will learn about the application of nanotechnology for bioprocessing. In today's lecture we will discuss the different role of nanoparticles in the field of bioprocessing. Okay, so we start today's lecture. We start today's lecture with introductory part. Okay, first we understand what is a bioprocessing. Bioprocessing is a branch of biotechnology. Basically, bioprocessing is a branch of biotechnology. In the field of bioprocessing, we discuss or we learn or we study the biological transformation of material into a desired product. Okay, what is a bioprocessing? Bioprocessing is a study in which we transform the biological material into a desired product. Okay, in bioprocessing, we include the enzymatic biocatalysis, fermentation, mammalian cell culture for the production of therapeutic proteins, high value small molecules, and the associated bioseparation need to obtain a product of adequate purity for the ultimate applications. Okay, basically in bioprocessing we use a lots of basically the main instrument of bioprocess is bioreactor. In this bioreactor we perform our whole bioprocessing process. In this bioreactor we add substrate or raw material plus biological organisms. Biological organisms. Biological organisms may be maybe bacteria, maybe yeast. Okay, and this viruses and this yeast is responsible for the conversion of raw material into a desired product. And this whole process is performed under this bioreactor. Bioreactor is a type of instrumentation in which this conversion process will perform. There are a lots of factors that are responsible for the manufacturing of this desired product, and there are a lots of parameters that are set according to our result into this bioreactor. Okay, bioprocessing is a multi-billion dollar a year industry with growth rate in some sector of up to 20% annually. In addition to provide a novel therapeutic that have evolutionized much healthcare, bioprocessing will play a critical role to provide a clean energy for the 20th energy. Okay, no nanoscale particles. Nanoscale particles play a most important role in the field of bioprocessing. Basically, these nanoparticles or nanoscale particles plays a most important role in three main sectors. And the first sector is enzymatic biocatalysis, second is biological separation, and third is a microbial and mammalian cell culture. These are the three main branches of biotechnology in which nanoparticles plays a most important role. Okay, first we discuss the inorganic material. What is an inorganic material? What is an organic material? Inorganic material is composed with minerals. Okay, the example of inorganic material is metal and metal oxide. This inorganic material does not contain organic compound. It does not contain carbon. Or this organic compound has been used in the conjugation with biological application for many years. Inorganic materials are increasing the interest in biological field whenever we compare this inorganic material with organic materials because they have reusable, high mechanical strength, high resistivity to heat, chemical and microbial degradation. Okay, now we discuss what is a organic material. Organic material are those material which contain carbon, hydrogen, oxygen. Organic material includes organic compound such as urea, cellulose. Okay, for example, gold, silicon or silica, gold, silicon or metal oxide are some of the many types of inorganic material currently used for biological nanotechnology. These are the inorganic compound. First compound is gold, second compound is silicon and third compound is metal oxide. These both no, all these inorganic material plays a most important role in the field of biological nanotechnology. Okay, now first we discuss the gold inorganic material or gold nanoparticle. Now we discuss the gold nanoparticle. Gold nanoparticle is a type of inorganic compound. Gold nanoparticle has many desirable characteristics and contain a lots of advantages. That's why it has a lots of application in the field of nanotechnology. Golden nanoparticle is very biocompatible, non-toxic, non-immunogenic. Non-immunogenic to the cells. Okay, these gold nanoparticles are non-immunogenic for the cells. How we will conclude that golden nanoparticles are not immunogenic for the cells? Because we investigate the endocytotic uptake of golden nanoparticles in RAW264.7 microfarad cell. Whenever we using the different microscopic techniques, and these techniques are atomic force microscopy, confocal laser scanning microscopy, and transmission electron microscopy. Okay, and whenever we investigate this whole process, then will we conclude that golden nanoparticles is non-immunogenic to the cells. Okay, and this golden nanoparticle does not cause secretion of inflammatory cytokinins or affect the amount of reactive oxygen and nitrate in the cells. Golden nanoparticle is very biocompatible material that have lots of application in the field of nanobiotechnology or nanomedicine. And these golden nanoparticles play a most important role in cancer therapy and cancer imaging. Okay, now we discuss the next inorganic material, that is a silicon or silica nanoparticle. One of the most widely used material in the nanotechnology industry is a silicon. There are lots of many fabrication techniques in which this silicon plays a most important role. Okay, silicon has long been used in electronics, lithography, and gaining popularity in the biological world. This element is related to the silica or silicon dioxide, are becoming biomaterial as the world of nanotechnology and biological combine. Okay, silicon and silica are widely used a variety of different applications included bio separation, cell culture, and enzyme stabilization and biosensing. Okay, silicon or silica have a many unique property. This silicon or silica nanoparticles contain a lots of unique property. That's why this material is so much versatile and have a lots of application. These pores allow the pores of silicon nanoparticles allow the high surface area, therefore high loading capacity. That's why we use this silicon in a target drug delivery. Okay, porous silicon is also biodegradable in aqueous solution, breaking down the siliceous acid. Okay, since porous silicon has these property, it is the ideal material for cell culture, for for size and charge based biomolecule separation. Basically, these silica nanoparticles plays a most important role in size exclusion chromatography. Most important role for the fabrication technique. To make a biomimetic compound. These are the major fields in which this silicon nanoparticles plays a most important role. Due to the porous nature of the silicon nanoparticle, we can easily design silicon nanoparticle for the target drug delivery system. Okay, and we also use this silicon nanoparticle in bio sensing, stable enzyme stabilization, and cell culture and bio separation. Now we discuss the next inorganic material that is a metal oxide. Okay, what is a metal oxide? Metal oxide is a what is a metal oxide? Metal oxide is a type of inorganic material. Okay, metal oxide are composed formed whenever metal and oxide, metal and oxygen. Typically, an oxygen is a anion and metal is a cation. Okay, depending on the metal associated with with the oxide, the physical and chemical property of the metal can be different. Okay, now we understand what is a metal oxide. Whenever metal react with oxygen, then it will form metal oxide. Okay, whenever metal react with oxygen, then it will form metal oxide. Whenever this process will perform, then physical and chemical property of metal will modify. Okay, metallic oxide are large structures that contain metalline and oxidine. ठीक है? Why it will contain metal and oxygen? Because metal oxide is made up of metal and oxygen. Okay, the attraction between these ions are strong, require a lot of energy to break the bonds, leading to the high melting and boiling point. Okay, these oxides are incapable to conducting the electricity. These metal oxides are unable to conduct the electricity whenever these metal oxide is in its solid state. Okay, but whenever these metal oxide is converted into the whenever electrolysis process will perform, then this solid metal ion will convert it into the molten state, and this molten state can conduct the electricity. Because why? In molten state these metal and oxide are conduct electricity, because these metal or metal oxide contain both positive ion or negative ion. That's why in liquid state or in molten state the metal oxide act as a conducting element. Okay, that's why these metal oxide contain a lots of application in the micro in the electronic field. Okay, molten metal oxide can conduct the electricity because the movement and discharge of ion present. Okay, some metal oxide also have a magnetic property which can make them useful in a variety of field. First property is a metal oxide in a molten form is a conducting element. It is a conducting element. Second most important property is magnetic property. Some metal oxide contain the magnetic property. That's why these metal oxide plays a most important role or application in different sector. Okay, nanoscale metal oxide are currently used a vast number of applications including gas sensing, solar cell, fuel cells, and data storage. Okay, metal oxides such as nickel oxide, zinc oxide. Metal oxide is a metallic oxide of nickel. Zinc oxide is a metallic oxide of zinc. Are also used in a nanotechnology in biosensing, magnetic bioseparation, as well as protein and cell absorption. ठीक है? And nickel oxide plays a most important role in for nickel oxide was used nickel oxide plays a most important role in non-enzymatic glucose sensing. Okay, now we discuss the next component, that is a carbon. It is a type of organic material. Okay, carbon comes in a many different form, referred as a allotropes. Carbon nanotube, that is a CNT, and graphenes are just two of the many allotropes of carbon. This CNT and this graphenes is a type of nanoparticle. Okay, this carbon contains lots of unique property. Similar to the difference between diamond and graphite, carbon nanotubes and graphenes have a different property for each other. This carbon nanotubes contain different property and this graphenes contain different properties. These both nanoparticles are very different to each other. That's why these elements contain a lots of application in nanobiotechnology. Nanobiotechnology. Okay, first we discuss the CNT. What is a CNT? CNT is a carbon nanotubes. Was first discovered in 1991. Has been great interest even since. Okay, now we discuss the CNT. CNT is discovered in 1991. These structures have intriguing characteristics, and these characteristics are chemical stability, high surface area, easy size manipulation. Okay, these unique property allow the CNT to have a many different biological application, included the transport of biomolecules, biosensing, and cell culture. Okay, these are the many different kind of biological sensing that employ CNTs. Often CNT are combined with biological structure to allow the better bioavailability. Okay, in one case Single wall CNT was coated with double-stranded DNA for the sensing of hydrogen peroxide or glucose. Okay, now carbon nanotubes is also a type of organic material. There are two types of CNT. First is a single wall CNT, and second is a multi wall CNTs. Both single wall and multiple wall CNTs plays a most important role in nanobiotechnology. We use CNTs for target drug delivery in biosensor to make a biomimetic compound. Then these biomimetic compound also have a lots of application in biological system. Okay, these are the some application of, okay, then in electronic field, electronic industry, medical industry, okay, these are the application of CNT in a field of nanobiotechnology. Okay, now we discuss the next, that is a graphene or graphene oxide. Graphene. Graphene is another allotrope of carbon that is composed of one atom thick parallel sheet of carbon atom that are bound together in a honeycomb lattice, giving the two-dimensional structure. Okay, graphene can also be described as a unrolled CNTs. Okay, as seen in similar to the CNT, graphene also have a application in biosensing, field effect transistor, fluorescence, fluorescence resonance energy transfer biosensing. Okay, this graphene and graphene oxide plays a most important role in biosensing, in field effector, field effect transistors, in fluorescence resonance energy transfer. Okay, graphene CFT. Graphene CFT means graphene field effective transistor device has been constructed for living cells detection, while graphene RFET, that is a Fluorescence, resonance, energy transfer biosensor is used to detect the DNA. This is used to detect DNA and this is used to detect living cells. Okay. Graphene can easily biofunctionalized with a variety of biological molecules of its large two-dimension structure. Okay, graphene is basically 2D structure. Okay, the structure permit proteins such as enzyme to be immobilized on the surface. Graphene is also utilized in cancer research, particularly for cancer imaging. Okay, now we discuss the next component, that is a polymer. Okay, polymer is a macromolecule composed of smaller repeated structural unit called monomer. Monomer form polymers is the process is known as a polymerization. For example, cellulose. Cellulose is a polymer of glucose, and the process by which we form this polymer, that process is known as polymerization. And this cellulose is known as a polymer and this glucose is known as a monomer. Whenever n number of monomer will join together and form polymer, and this process is known as polymerization. Okay, polymer are very diverse, being composed from both natural and synthetic material, and this polymer have a high molecular weight. Okay, there are many different types of polymer included: natural occurring, biopolymer. An example of some polymers are nucleic acid, protein, carbohydrate, lipid. Nucleic acid is a polymer of nucleotide. Protein is a polymer of amino acids. Okay. Polymer are now widely used in many nanobiotechnology purpose. Both synthetic and natural occurring polymers their place in the have found their place in this field. Which field? In the field of nanobiotechnology. There are several types of synthetic biocompatible polymers include the hydrogel and PDMS. PDMS plays are used in a fabrication technology. Okay. Next, our natural occurring biocompatible polymer receive increased attention is chitin and chitosan. Chitosan. Okay. All of these polymers have a wide variety of possible application, including detection, biosensing, protein binding, microfluid device for extraction, membrane for cell culture, and antimicrobial application. Okay, these are the application of polymers. First is, as we easily use this polymer as a biosensor, as a protein binding material, as a microfluid divided for extraction, membrane for cell structure, and antimicrobial application. Okay, rather than this, these lipid are polymer known as a liposome. And this liposome is a type of nanostructure, which is a type of nanostructure that is made up of phospholipid, and this liposome is used for the target drug delivery system. Okay, next we discuss the biological chemistry and manipulations. Okay, beside the use of new material for biotechnology, there are also many different kinds of chemistries and biological manipulation being applied for uses in this field. Okay, in this field we use different types of chemistries and biological manipulation for enhance the application of the nanomaterial or biological. Beside the use of new material for nanobiotechnology, there are also many different kinds of chemistry and biological manipulation being employed for uses in the field, in this field. Okay, to form a new material for nanobiotechnology, we also manipulate and apply the lots different kinds of chemistry and biological manipulation. Why? For what? For increasing the application of new material in the field of nanobiotechnology. Okay, many natural occurring reactions such as substrate channeling are being studied and exploited for the use in a variety of chemical processes. Okay, conjugation of chemistry with the biological are also being used to improve the biological separation and detection of. Now we discuss the first biochemistries and biological manipulation process. First is a substrate channeling. A type of manipulation that is being exploited is a substrate channel. What is a substrate channel? Substrate channel is a process for for manipulation of nanotechnology, nanomaterials or new material. And these material plays a most important role in a field of nanobiotechnology. Okay. Yeah. Substrate channel occur when the intermediate product formed from an enzyme is transferred to another neighboring enzyme without allowing the intermediate to equilibrium in a bulk phase. What is a substrate channeling process? Substrate channeling process is a type of process in which intermediate from one enzyme intermediate product of one enzyme is transferred to the another neighboring enzyme without allowing the intermediate to equilibrium in a bulk phase. Okay, this process can occur in vivo, ex vivo, or in vitro. in vitro naturally. But there are many benefits to constructing synthesis complex from substrate channeling for biological biotechnology purpose. Okay, substrate channeling allow for fast reaction rate when compared to free floating enzymes, as well as protective unstable intermediates, obstructing substrate competition among the different pathway, and enhance the enhancement of biocatalysis while avoiding the unfavorable energetic of substrate. Some of these synthetic complexes include multifunctional fusion proteins, complex linked with scaffolding, synthetic cellulosomes, recombinant cellulitic microorganisms, and the co-immobilized co-immobilization of multiple enzymes. Okay, what is a substrate channeling process? Substrate channeling process when a intermediate product of one enzyme is transferred to the neighboring enzyme, but without allowing the intermediate product from without allowing the intermediate to equilibrium in a bulk phase. Why will we use this process and what is the benefits of this substrate channeling process? By the performing this substrate channeling process, we easily increase the rate of reactions as compared to free floating enzyme, and we also protecting the unstable intermediate, obstructing substrate competition between the different pathways, and enhance the biocatalysis. Okay, that's why we apply this substrate channeling process. Now we discuss the application of nanotechnology to bioprocessing. First is a enzymatic reaction. Okay, enzyme are enzyme, also known as a biological catalysis, are widely used for a variety of application, included synthesis of pharmaceutical intermediates, production of food product, detergent, and production of space specialty specialty chemicals or special chemical, or production of specialty chemicals. Enzymes are able to catalyze a broad range of chemical reactions, including hydrolysis, oxidation, reduction, polymerization, etc. In addition, enzymes are able to work under the mild condition, include the near ambient temperature, neutral pH, aqueous environment, making them highly favored for green engineering. Okay, these enzymatic reactions are very important in a field of medical sector. Second is a cofactor immobilization. A final area of enzymatic biocatalysis that many benefit for the introduction of nanotechnology is for reaction that require cofactor addition. What is a cofactor? Cofactor is a non-proteinaceous part of enzyme. This is a non-proteinaceous part of enzyme. Okay, and this cofactor is required to enhance the biological activity of this enzyme. Okay, the most common cofactor desired for industrial biocatalysis and electron carrier required for redox reaction is NADH. NADH is a type of cofactor. Okay, these cofactors is quite expensive, are consumed in stoichiometric quality for each enzymatic reaction. They can be regenerated by the additional redox reaction and then reused if they are retained near the original enzyme. Okay. What is a cofactor? Cofactor is a non-proteinaceous part of enzymes. Okay. This enzyme is made up of two parts. First is a proteinaceous part and second is a non-proteinaceous part. And combinedly proteinaceous and non-proteinaceous part is known as a holoenzyme. This proteinaceous part is known as a apoenzyme. And this non-proteinaceous part may be known as a cofactor. Example of cofactor, NADH. This NADH is required for performing the redox reactions. And this redox reaction is main reactions in our metabolic system. That's why this cofactor plays a most important role. Okay, and without this cofactor, enzymes can't perform their activity. Okay, now we discuss separation. What is a separation? For understand, it is a container. In this container, two types of mixture is present. Okay, this is the component A and this is the component B. Okay, now we want to separate both these components, A and component B. Component A and component A and component B. Then we will perform a process named as a separation. What is a separation? Separation is a process by which we distinguish the mixture of different compound. Okay, and this separation is based on a size, charge and density, surface activity and biological affinity. Okay, we easily separate the biological molecule by the process of separation, and this separation is based on a size, charge, density, surface activity, biological affinity, etc. The majority of applications are in the separation of proteins occurring nucleic acid to obtain a material of the desired purity for industry diagnostic and therapeutic uses. Another important application is peptide separation for the growing field of proteomics. Okay, if we want to separate protein, then we perform separation process. If we want to separate diagnostic material, then will we perform separation process. If we want to separate therapeutic compound, then we also perform separation process. Basically, separation process is a type of downstream processing technique, and this process is performed after the fermentation process. Okay, what is a proteomics? Proteomics is a branch of science in which we study the proteins. The proteomic research, proteins are digested with the protease into the peptide that are then separated before analysis by the mass spectro process. Mass spectroscopy, yeah, mass. Okay, what is a proteomics? Proteomics, in proteomic research, suppose this is a large protein. Okay, then we treat this protein with the help of protease enzyme, and this protease enzyme will digest this protein and convert it into the peptide. Okay, now we want to visualize this protein under the mass spectroscopy for further study. So, before performing this mass spectroscopy, we perform the separation technique. Okay, and basically in separation technique we use the chromatography. What is a chromatography technique? Chromatography is a type of technique. What is a chromatography? Chromatography is basically a separation technique. In chromato, there are a different types of chromatography, but for the separation of protein, here we separate the protein on the basis of their size. That's why here we use the size exclusion chromatography. Okay. In macroscale separation, two of the most commonly used techniques are membrane separation, in which compounds are primarily separated by size, with large compound being retained by the membrane and small compounds particles flowing through the membrane pores, and chromatography, in which compounds preferably partition between the solid and mobile phase depend on a charge, size, hydrophobicity and biological affinity. Both of these separation techniques can be expanded into the nanoscale using the nanoparticles or nanostructure materials. Okay, now we understand the separation. If we perform the membrane separation process, then we use the membrane according to our requirement, which types of material we want to separate. If we want separate the material at nanoscale, then we use the nanofiltration or nano size membrane or nanofiltration technique. If we want to perform chromatography, this is a very common technique that are used to separate the material. Okay, and second technique is membrane separation. Suppose this is a membrane. and we want to separate out our material. Okay, this is a membrane. Then we pass our sample or solution in this membrane. Then small size particles will moved out, and its large particles are collect on this membrane. This is a membrane separation. If we perform chromatography technique, then there are a lots of chromatography techniques are available in the market. If we want to separate the molecules on the basis of charge, then we on the basis of their size, then we perform size exclusive chromatography. Then if we want to perform their if we want to separate the molecules on the basis of their affinity, then we perform affinity chromatography and gas chromatography, HPLC chromatography. There are lots of techniques are available in the market for the separation process. Okay, now next we discuss the nanoparticle for bioseparation. Majority of nanoparticles used for bioseparation are magnetic nanoparticles. Due to ease of separation by the application of magnetic enzyme immobilization, in generally the particles employed are supramagnetic, hence they do not allumate in the absence of magnetic field what can easily collect with the strong permanent magnet. Affinity separation, which is based on a specific biological and chemical interactions, are commonly reported, although the ion exchange particle has been reported. Ion exchange is a type of chromatography technique in which we use cation and anion for the separation of molecules. Okay, for the biological separation, basically we use the magnetic nanoparticles. Okay, if we perform affinity separation, then we use affinity chromatography as well as ion exchange chromatography. A wide range of chemistry has been investigated for the functioning of magnetic nanoparticles. The most common affinity purification at both macro and nano scale is bind to the his tagged protein. Typically 6 histidine residue at amino and carboxy terminus of protein via the immobilized metal ligand. Most commonly nickel. Building on their previous work, creating magnetic nanoparticle for drug delivery and medical imaging. Okay, prepare supramagnetic nanoparticle by standard chemical precipitation method, followed by the surface modification using the phosphonomethyl amino diacetic acid. Okay, the PIDA functionalized nanoparticle were then linked with nickel for purification of 6X histidine tagged protein with phosphate group of PMIDA ligand acting as a surface anchoring agent on magnetic nanoparticle, and remain free carboxylic group are available for binding with the nickel ions. Next we discuss the nanostructure material for bioseparation. The most commonly used nanostructure material for bioseparation are nanoporous membrane. The size of this membrane is in a nano range. Okay, nanoscale membrane employed a separation bio macromolecule or nanoparticle can be fabricated from nanoporous anodic aluminium membrane, anodic alumina membrane. carbon nanotubes membrane, nanoporous silicon membrane, one-dimensional nanorod nanotube membrane. Okay, membrane separation can be performed on the basis of size, charge, affinity. Okay, and some separation are combination three with these three parameters. Okay, the driving force can be either pressure, electropoietic and electroosmotic. Okay, size-based separation are most obvious application of membrane and membrane with micrometer and nanometer size. Porous has been extremely used for separation of cells, virus, proteins, typically under pressure driven flow. Okay, in general, these membrane has been polymeric such as nitrocellulose, nylon, polysulfone, etc. with fairly broad porous distribution leading a partial retention of many compounds. Okay, basically for the bioseparation process we use the different types of biological nanostructure. In these biological structures are AAM, that is a anodic alumina membrane. Next, CNTs, that is a carbon nanotubes. Next, nanoporous silicon. Next, one-dimensional nanorod or nanotubes. And by the help of these nanostructures or nanoparticle, we separate the biological material on the basis of their size, charge, and affinity. Okay, and these biological membrane or nanostructure, these nanostructure membrane is used to separate the virus, proteins, viruses, proteins under the pressure driving flow. Okay, but in generally for the separation process we use the polymeric membrane, or these polymeric membrane is made up of nitrocellulose, nylon, etc. Okay, now we discuss the next application, that is a cell and microbial culture. While nanotechnology has been applied extensively in a wide variety of cell culture activity, including the tissue engineering, drug delivery, and biosensor. Okay, the focus. Now we discuss the next application, that is a cell and microbial culture. While nanotechnology has been applied extensively in a variety of cell culture activity, including the tissue engineering, drug delivery, and biosensors. Liposomes, dendrimers, dendrimers, CNTs, metal oxide nanoparticle, metal nanoparticles, for example, zinc nanoparticles, gold nanoparticles. These are the nanostructures and these are responsible for the tissue engineering, drug delivery, in nanobiosensor for the formation of nanobiosensors, etc. Mammalian and okay, these are the nanomaterial and this is the application of these nanomaterials. Okay, Mammalian and microbial and mammalian cell culture for production of recombinant protein therapeutics, industrial enzyme diagnostic protein compromise a core of biotechnology and biopharmaceutical industries. Okay, therapeutic proteins range from small peptides such as insulin to large antibodies and enzymes. Microbial mammalian cell culture are very useful for the production of recombinant protein, therapeutic and industrial enzyme and diagnostic protein. Okay, compromise the core of the biotechnology and biopharmaceutical industries. These are the main component of these recombinant protein, therapeutic drugs, and industrial enzyme and diagnostic proteins are the core part of biotechnology as well as biopharmaceutical industries. Therapeutic proteins range from small peptides such as insulin to large antibodies or enzymes. Okay, there are nearly 20 recombinant protein, monoclonal antibody, and nucleic acid based drug currently approved with the market greater than $50 billion a year. Okay, and growing at the rate of 20% annually. Next, cell culture substrate. A variety of nanopattern and nanostructure material has been used for mammalian cell culture. Mammalian cell culture is important for the production of recombinant protein, therapeutic drugs, etc. Why these compounds are the main or core compound? These are the core or main compound of biotechnology as well as bio pharmaceutical industry bio. Okay, and in this field this nanopattern and nanostructures plays a most important role. A number of recent study has been explored the use of nanoscale material for culture a number of cell types including the CHO cells. While it is not clear that these cell culturing will have direct applicability in bioprocessing or could envision that they might be used for cell screening study or media optimization. Okay, these membrane at 15 nanometer thick, approximately 100 times thinner than the polymeric membrane. Okay, exhibit the permeability of a small solute to order the magnitude of greater than the conventional membrane. A nanomembrane that is known as PNC silicon membrane were quite biocompatible, showing the comparable result to cultures performed on a polystyrene or glass. Okay. Okay, the PNC silicon membrane are dissolved in cell culture media over several over the over several days without cytotoxic effect. Okay, on the PNC silicon membrane, we easily culture our cell. We easily culture or grow our cells over the several days without any cytotoxicity. Okay, and this membrane is first very very thin, and these membrane are biocompatible. Okay, Okay, that's why currently we use this nanostructure based memory for the culturing of cells. Okay, now we discuss the next application, that is a delivery of nucleic acid process and small molecule cells. वो तो इनसे ले लूंगी. Okay, चलो. Here, देखो here magnetic nanoparticle plays a most important role for deliver the nucleic acid. Okay, okay. In in Chinese hemisphere ovary cells, we easily transfer the nucleic acid by the help of these magnetic nanoparticles. Okay, the magnetic nanoparticles is used for deliver the nucleic acids. The magnetic nanoparticles are available in the market which are used to deliver the nucleic acid into the cells. Okay, while these has been used variety of cell line, these nanoparticles are used presently in different cell line for transferring or delivering the nucleic acid. Them we attempt we attempt to use them to deliver nucleic acid into the Chinese hemisphere ovary cells. This is the work ovary cells, the workhouse of biotechnology industries. Grow the where the workhouse of biotechnology industry grown in a 3D collagen hydrogel as a precursor of high throughput screening of silencing RNA or short hairpin RNA. Silencing 3D collagen hydrogel as a precursor of high throughput screening of silencing RNA, that is a siRNA, or short hairpin RNA, that is a shRNA. Okay, next. Also synthesized a novel magnetic particle with 5 nanometer iron oxide core. Okay, using a ligand exchange system or ligand exchange reactions to coat the iron oxide particles with low molecular weight branched or polyethylene amine, that is a PEI. These coated supramagnetic nanoparticles where they used to condense the siRNA or plasmid RNA, forming a small particle size magnetic complexes. Okay. Rather than the magnetic nanoparticle, we also synthesize the novel negative particle with the core of 5 nanometer iron oxide core using a ligand exchange reactions to coat the iron oxide particle with low molecular weight branched polyethylene amine, that is a PEI. These coated supramagnetic nanoparticles were used to condense the Si or plasmid DNA, forming a small particle size magnetic complex. Then this complex can easily deliver into the cells. Okay. It was also reported that uptake of SWNT via variety of cell types. This SWNTs is easily uptake by different types of cells, and these cells may be HLC60 cells, Jacquet cells, Chinese hemisphere ovary cells, and 3D3 fibroblast cells. These cells easily uptake this SWNTs complex, and they are then able to biotinylate the SWT using the EDC and biotin LC amine, and finalize we create the SNT biotinide streptovidin complex. Okay, and this complex is easily taken up by the cell. Okay, the presence of SWNTs and streptovidin in the endosomes indicate indicate an uptake pathway consistent with the endocytosis process. We also use this approach for transferring the nucleic acid into the cells. First we use the magnetic based nanoparticle. Second, we use the novel magnetic nanoparticle with the core of iron oxide, and third we also use the STNT biotin streptomidine complex for the delivering the nucleic acid into the cells. This is all about today's lecture. In today's lecture, we will discuss the different types of molecules which have a lots of application in a field of nanotechnology as well as bioprocess engineering. Thank you so much for watching my video. Please follow IDLS Academy on Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and also get it on Google Play Store. Thank you so much for watching my video. Please like, share and subscribe IDLS Academy. Thank you.